Welcome everyone to part 2 of the Capstone Project Solutions. Let's head back to the notebook to where we left off last time. Alright, we're back here in the notebook, and now we reach the part of the notebook where we want to compare Fandango ratings to the other sites to see if the discrepancy goes beyond just the displayed rating versus the numeric rating it has internally. Let's go ahead and now compare Fandango ratings to things like Rotten Tomato ratings and Metacritic ratings. So we have this all sites scores.csv. Go ahead and run this cell to read it in, and then we're going to explore the data frame. So if we take a look at the data frame, maybe just the head of the data frame, we can see right here that there's the film title column, the Rotten Tomatoes score, a Rotten Tomatoes user score. So Rotten Tomatoes has both critics and then it has the user itself. We have the Metacritic score versus the Metacritic user score. So kind of the same thing. Metacritic has this overall score from 0 to 100, and then there's what the users score. And then we have the IMDb score, as well as the vote counts for Metacritic, as well as IMDb. All right, so we can also do things like check out info on it. You'll notice we have 146 entries, so a little less, or quite a bit less than the Fandango, but recall the Fandango dataset had a bunch of movies with no reviews. So essentially what we have here is the all sites data frame that has the movies where Fandango had at least 30 reviews. And then if you want, you can also say describe, and then explore the statistics here on the various columns. So moving along to first Rotten Tomatoes. So we're going to first take a look at the Rotten Tomatoes, and if you've never used Rotten Tomatoes, you know that Rotten Tomatoes has actually two sets of reviews. Basically what they have are their critics' reviews, which are published by official critics. So if someone publishes a critique in a newspaper about a movie and they score it, basically Rotten Tomatoes says, was their score positive or negative? And then it creates some sort of percentage there. And then there's actually the user reviews, where a user either likes or dislikes a film, and then they have these two separate reviews. So what we're going to do is first explore the relationship between the critics' reviews and the Rotten Tomato user reviews. So we can do this many ways. One way to do this is just with a scatter plot. And we know we can say sns.scatterplot, pass in the all sites data frame we just read in, and then I'm going to choose X as Rotten Tomatoes, which is the label for the critic score, and then Y is Rotten Tomatoes underscore user, which is the user score. So when you run this, by default, we get this sort of linear relationship, which kind of makes sense. If people like the movie, it's very likely that also critics will like the movie. There are a few outliers. So we can see up here these 2 points. That basically means that critics didn't like this movie, but users really liked it. And if there was a point over here, that would mean that the critics really liked the movie, but the users didn't. So it looks like on average, users are kind of liking movies more than the critics, but again, it's a general linear relationship here. And we can see this cluster of movies that pretty much everybody liked, critics and users. Okay. So what can you do? If you want, you can start editing the limits or the figure itself. So we came down here and we put it from 0 to 100 and 0 to 100 here for both X and Y limits, just to make the plot kind of a little clearer. You'll notice by default, the Rotten Tomatoes user Y-axis doesn't start at 0. And in general, I would suggest that for most plots, you start the Y limit at 0 in order to just make it clear the actual scale of the results. So we're going to say go from 0 to 100 for both of them, run that, and we can see again the relationship here. And if you want, you could also say PLT figure, and then edit the DPI to something higher. Okay, so again, lots of adjustments you can make. And what we can also do is quantify this difference by comparing the critics rating to the Rotten Tomatoes user ratings. So essentially what we want you to do is create a new column of that difference between the Rotten Tomatoes critics rating and the Rotten Tomatoes user rating. And we want you to calculate this with Rotten Tomatoes minus Rotten Tomatoes user. So what that means is that if we have a really large positive value, that means critics really liked it much higher than users. Because you can imagine if a critic rated it 100 and users overall rated it 0, then the difference would be 100. So a large positive value means critics liked it a lot more. And then the reverse is a large negative value, which means users, on average, are rating it much higher than critics. This is pretty easy to do. We simply say all sites, and I'm going to call it Rotten Diff. And I'm going to set that equal to all sites, and then Rotten Tomatoes minus all sites, Rotten Tomatoes user. Okay, so we have that difference, And then what we can do is calculate what's known as the mean absolute difference. And essentially what that is recall that this value of Rotten Tomatoes minus Rotten Tomato users could be either positive or negative. And if somebody asks you, on average, how far off are user ratings than critics' ratings, you can't really just average out all the numbers. Since some are positive and some are negative, you could start getting closer to 0. So what you need to do first is take the absolute value of them and then take the average, because we're dealing with both negative and positive values. So sometimes you'll have higher critic ratings and other times you'll have higher user ratings. So what we want to do to get the average difference between critics and users, we're going to take rotten diff that we just created, apply the absolute value, and there's many ways you can do this, and then just take the average. And here is the average differential between Rotten Tomato scores by critics and Rotten Tomato scores by users. And again, this is average of the absolute, so it kind of could be average in either direction. It's just the absolute difference in rating. So 15% is pretty significant. So let's go ahead and actually plot this out. And essentially the task asks us to plot out two versions of this distribution. One are the true differential values, so we can see it's more or less centered at 0. And the other one is the distribution of the absolute difference here, just so we can see on average how far off we are. Keep in mind, these are really showing the same thing, it's just how you want to think about it, of the actual differences. Are we getting more negatives or more positives, or just how far off are we on average? So let's go ahead and quickly create these plots. As you can tell, they're just simple hist plots. So we're going to say sns.hist plot. And then I can say here x, or data, is equal to all sites. And then x is equal to rotten diff. And if you just run this, you'll pretty much get the plot. So everything else is just customizing it. So we can add in the KDE to say it's true, expand the bin size a little bit, and then I can also enlarge that figure. So I can say PLT figure, fig size, maybe let's have this be 10:4 with a higher DPI. Whoops. DPI is equal to, let's say, 200. And here's the plot. Okay, so this is again showing the distribution. Looks like there's maybe 1 or 2 movies here that are highly negative. Again, that means users are really liking the movie compared to the ratings of the critics. And here, there's just maybe 1 or 2 or 3 movies that the critics really seem to enjoy, but the users did not. And if you want to switch it and just show the absolute value, the way you can do that is essentially the same thing, but what you can do here is actually just pass in x directly as the column we just had here. So we can say all sites rotten diff apply absolute. This is one way you can do it without having to kind of define the column within. X can actually take in the raw series, run that, and you get the same plot. Or if you want, you could have made the absolute values, applied them first, and then set that as a new column within the data frame, and then just repeat. Okay, so after this, we just created those 2 plots. Let's go ahead and find out which movies are causing those largest differences. So what we're going to do is we're going to see off of all sites, what are the top 5 movies users rated higher than critics on average? So if users are rating it higher than critics, because we calculate it as critics minus user score, then we're looking for the largest negative values. In other words, we're looking for n smallest of that difference. So let's go ahead and grab the 5 smallest for rotten diff. You run that, and you should get these movies. Do You Believe, Little Boy, Hitman Agent 47, The Longest Ride, and The Wedding Ringer. And if you want, you can just grab the film title, and it's these films. You can also grab the rotten difference here if you want. So these are the movies that users really liked a lot more than critics. Okay, and then the opposite are now show the top 5 movies critics scored higher. So it's essentially the exact same thing. You're just going to do it backwards, which means we can copy and paste this. Except now what we're going to do is we're going to say to go to n largest. So change n smallest to n largest. And now you should see those movies. Mr. Turner, It Follows, While We're Young, Welcome to Me, and I'll See You in My Dreams. Okay, so again, these are the movies that critics really liked, but users didn't really like them that much. Now let's go ahead and move on to quickly analyzing Metacritic. So what we're going to do here is just see if there's a relationship between the Metacritic score and the Metacritic rating. So recall here that these are actually on different levels. Metacritic user scores here are going from 0 to 10. and the Metacritic score is going from 0 to 100. So it's essentially the exact same plot that we saw earlier. So what I can actually do is come up here to our previous scatter plot and essentially reuse the same code. So I'm going to grab this, come back down here, and paste it in, and essentially change the X to match up with what I have here. So X is going to be Metacritic, and then my Y is Metacritic user. And this is just comparing the Metacritic score versus the average of the Metacritic users. And let's go ahead and change this fig size to match up. We can say fig size is equal to, let's say 10 by 4. And whoops, looks like we kept the wrong Y scale. So let's fix that to go from 0 to 10. And there we have it. Okay, so again, clearly a kind of linear positive relationship. As the users score it higher, on average, the Metacritic ratings also go higher, which makes sense. Okay, and it doesn't also look like there's any extreme outliers like we had with Rotten Tomatoes. Recall Rotten Tomatoes, we kind of had some outliers over here because of these movies, specifically Do You Believe Little Boy, and then the other one's Mr. Turner and It Follows. So let's go ahead and keep moving on. We'll go ahead and do IMDb. Kind of a similar thing here. We're just going to compare the user vote count for Metacritic versus IMDb. So what we want to explore here is a relationship between vote counts. Are there some movies that are super popular to vote on IMDb and also popular to vote on Metacritic, or are there some that are only popular voting on one platform? And the way we can do this is, again, just with a scatter plot. So I'm going to do the exact same thing as we did last time. I'm going to copy this scatter plot code, and I just need to switch X and Y. So this is what's so nice about Seaborn. So what the X label is going to be is the Metacritic user vote count, and the Y label is just IMDb user vote count. Again, the task is just asking us to compare the vote counts for Metacritic versus vote counts on IMDb. And then it can be a little sneaky here, since I'm kind of copying off these expected values, and just copy these string codes. But obviously you could type these out yourself if you really wanted to. So comparing those two vote counts on X and Y off of all sites, go ahead and run this, and here we have it. So you'll notice right away, there's kind of 2 points that are outliers. And one is this point right here, where you have IMDb with a very high user count, but notice it's not actually super high on Metacritic. And what's also kind of interesting is, just in general, there doesn't seem to be a whole lot of movies that are going to get more than 50,000 IMDb votes or more than 500 Metacritic votes. What's also kind of interesting is this movie right here must have been one of the most popular movies, because you're looking at 300,000 votes on IMDb and over 2,000 Metacritic votes. So let's go and explore what this point is, as well as what this point is. So it's mentioned there's 2 outliers. So what's the movie with the highest vote count on IMDb that only has around 500 Metacritic ratings? How can we do this? Well, we can simply again use all sites and largest. Hopefully by now you're seeing just how useful a tool and largest and smallest is. And we'll say IMDb user vote count. So we run that, and you should have gotten the imitation game. So the imitation game is getting really high scores, but what's also important to note is while the Metacritic vote count was only around 566, it was absolutely blown out of the water by the number of users voting on IMDb, over 300,000 people. So that is this little dot right here, super high IMDb score, or IMDb user vote count, really. The next one is what movie has the highest Metacritic? So we're just going to copy this. Same thing here, except now instead of IMDb, it's going to be Metacritic. Run that, and you should have gotten Mad Max Fury Road. Again, high reviews, but what's important to note here is also high IMDb, but very high Metacritic user vote count. In fact, kind of blows out the water the other movies, because no other movie on Metacritic has even more than 1,500, and this one has over 2,000 votes. So kind of interesting, those 2 outliers. And now the moment of truth. So we're finally going to begin to explore, we have all these other ratings from these sites. How do they compare to those original Fandango scores that we were so interested in? So what we're going to do is finish off this project in part 3, where we get to really the meat of the question that we were asking ourselves at the very beginning. Is Fandango artificially showing us higher scores than they should based off what we know other people are rating these films as? Okay, I'll see you at the next lecture where we finish off the project.